Okay, here's this a video just on assignment 3.4, how to kind of do the questions. I'm not going to work all of them out, but I will kind of give you the basic outline and hopefully you can go from there. If you have any questions, feel free to email me. And remember, you can always like resubmit the assignment. So if you do it poorly and need to resubmit it, that's fine too. And so for question one, so we have a 325 Newton box is sliding down a frictionless incline plane. If the incline makes 30 degrees, so really what we have here, you always want to start by giving yourself kind of a drawing or a diagram what's happening. So we have a box, free body diagram on this box. We have FG going straight down. Remember, FN is always perpendicular to the surface. Again, then we have to think about like what is causing this box to fall down. So like where is it getting the force to actually accelerate down? And so in this case, it's going to be FG parallel. Okay, this is 30 degrees. Okay, so from there, yeah, like if the FG parallel is causing it to slide down, it's frictionless, so there's nothing pulling back on it. We just need to solve for FG parallel. We're given, I guess if we redraw this as a triangle just with our, this would be FG parallel, this is FG, this is FG perpendicular or normal force. And so from there, this would be 30 degrees. So we can now solve for FG parallel. Once we find that, then we're just finding the acceleration. So really like we'd use sine. So sine of 30 is equal to FG parallel over FG. So, and then FG, remember, is the 325 newtons. Okay, that will give us FG parallel. Once you have FG parallel, now you have to find the mass. So to find the mass, Fg is equal to mass times gravity. So mass is going to equal your 325 divided by 9.81. To find mass, now you can use just mass, or Fg parallel divided by mass will give you your acceleration down the incline. Okay, for question two, same type of things happening here, but now we have an extra force added to it because we have friction. So we have our incline here. This is 35, so that changes a little bit. Okay, we have our box sitting on it. The box is pulling down with force Fg. Fn's going straight up, or perpendicular, I guess, to the surface. This is the force going down is Fg parallel, but then there's also a force pulling it back, which is our force of friction, okay, which we're given here. So we have to find basically the balance between these two, like our F net is going to equal our Fg parallel minus our force of friction. Okay, so to find Fg parallel, you're basically going to follow the same steps you did here. Okay, make yourself a separate triangle. This is Fg perpendicular, or perpendicular, Fg parallel. This is Fg. So you're given Fg is 275 newtons. Okay, this would be 35 degrees here. Okay, force of friction's one down, so you have to find Fg parallel, subtract the 96 for your F force of friction. That'll give you F net. Again, you have to use this to solve for your mass. Okay, your Fg is equal to 275 in this case, divided by 9.81. That'll solve for your mass, and then you can find your answer for your acceleration. Okay, question three. These are labeled wrong on here. This is actually question three on your assignment. Okay, so a 9.6 kilogram object is pulled along a horizontal surface. What's the coefficient of kinetic friction? and what is the force of friction. So really, again, we'll give ourselves a diagram. This is horizontal, and so we have Fg pulling down, Fn equal and opposite in this case because it's horizontal. It's being pulled. So we have a force applied, and then we have a force of friction kind of pulling back on it. Okay. Our formula to find force of friction, in this case kinetic, is equal to the coefficient of kinetic friction times the normal force. So to solve for the force of friction, kinetic, we're given our coefficient of friction. We have to find our normal force. So again, Fn in this case is equal to, well, I guess it'd be equal and opposite, so negative Fg. So, and then Fg is equal to mass times gravity. So to find our force of friction kinetic, we can just go our coefficient of friction times our mass times acceleration due to gravity. And because it's equal and opposite, since Fg is negative, these would be positive. So we'll just keep a positive 9.81 to get your answer. Question 4, again, this is wrong. Question 4, this is question 3. Okay, a 435 Newton box is sliding down a 40-degree incline. So we'll draw our incline, 40 degrees. Okay, this box is sliding down. Okay, so that's from our force of gravity parallel. And then what's the force of friction? The force of friction is what's pulling back. Since it's sliding down, we know our Fg parallel is more than our force of friction. We're given, this is Fg, and then our normal force would go up perpendicular to the surface. And so if we draw our second triangle here showing our Fg perpendicular, Fg parallel, this is 40 degrees in this case, and then this is Fg. So for this one, again, like overall, F net in this case, to make it slide down, oh, I gotta move this up, sorry about that. Okay, F net is what's pulling it down here. So that's going to equal our Fg parallel minus our force of friction. So our force of friction, rearranging this, is going to equal our F net minus our force of gravity parallel. And so to find so we need to solve for F net and our force of gravity parallel. So since F net is equal to our mass times acceleration, here's our acceleration. Okay, our mass, again, we just Fg is equal to mass times gravity, so mass will equal Fg divided by g. Okay, so then we can find this mass, put it in here. This is our acceleration. That'll give us F net, and then force of gravity parallel, we'll use, again, sine, like, so Fg parallel sine of 40 equals Fg parallel divided by Fg. That'll solve for Fg parallel. This is Fg here. Okay, from that, you should be able to solve for that question. Okay, next couple of questions here. A 20 Newton object is placed on a horizontal surface. Okay, so again, we have an object on a horizontal surface. Okay, a force of 3 newtons is required to keep the object's movement at constant speed. That's a big one there. So constant speed means F net equals 0 because we have 0 acceleration. So that means that our force applied is equal and opposite to our force of friction. So since our force applied is 3 newtons, our force of friction is also 3 newtons. And then we know So our formula, force of friction equals the coefficient of friction times Fn. Okay, Fn is equal and opposite to Fg, so this is Fg. So really, like, to find our coefficient of friction, we're going to have our force of friction, 3, divided by our Fn, which would be 20. That'll give us the answer for that one. Next question, so we have 16.2 kilogram objects at rest on an inclined plane. If the incline makes an angle of 25, what's the normal force acting on the object? Okay, so again, we have our object sitting on inclined plane of 25 degrees. Okay, we're looking for Fn. Okay, and we can find Fg because we have a mass times it by the force of gravity. Okay, if we draw our second triangle over here, this is 25, this is Fg, this is 90. We want to find our Fg perpendicular, which is equal to our Fn. And so since we have Fg mass times gravity, we can solve for that. We're just going to use the Coase law and then find Fn. Okay, and then the last one, we have a 15 Newton object pulled up an incline. If the inclined plane makes angle 35, so this is 35 degrees. This one, our force applied is going up because it's being pulled up the incline. Okay, we have a coefficient of friction. Okay, so again, like our force of friction, that's what we're looking for, is equal to the coefficient of friction times Fn. So this would be Fn here. We're given Fg. This is our F, force due to gravity, or our weight. So again, we're going to do the same thing as we did up here. Okay, find your Fn and then just times it by your coefficient of friction, and you should be able to get the answer. All right, let me know if you have any questions. Hopefully that was good enough to get this assignment done.